Alright, and welcome to Quadratic Inequalities, Level 3. Now, in example 1, much like Level 1 and 2, it just asks us to find the solutions. Okay, and so we have f of x is greater than or equal to 3x squared minus 10x minus 8. Now remember two things. One, my solutions are over here. They are on the right-hand side. And two, we always want to set f of x equal to 0. So what do you think our first step should be? Well, in this particular case, we need to flip this whole thing. So we really want to write it like this. 3x squared minus 10x minus 8. And think about this. If this whole thing is flipping, what's going to happen to this greater than or equal to symbol? Well, it flips as well. And then, of course, we're going to set this equal to 0. Now, the next thing I notice is that my a value is not equal to 1. Well, I can't divide 10 or 8 by 3, so we're going to have to use a different method. Remember, we have two options at our disposal. We can either use factoring by grouping, or we can use the quadratic formula. For example 1, I'm going to use factoring by grouping, and for example 2, I'm going to use the quadratic formula. But remember, they're going to give you the same answer. Okay, so how in the world do we do this? Well, we take a look at our C term, which is negative 8, and we say, well, what two things multiply to be negative 8, but, oh, I'm so sorry, y'all, I almost made a mistake there. Not negative 8. Remember, with factoring by grouping, you take your A term and you take your C term and you multiply them together. So we have 3 times negative 8, 3 times negative 8, which is negative 24. And now we're looking for two numbers that multiply to be negative 24, but add up to be negative 10. Okay, so what are some of my options? Well, I know I could do some combination of 1 times 24, some combination of 2 times 12, and some combination of 3 times 8. And if that 24 is negative, I'm not adding them to get to 10, I'm subtracting them to get to negative 10. And here, I would say let's look at 2 and 12. Okay, if the 10 is negative, that means the larger number is negative. Let's just ask ourselves, is 2 minus 12 equal to negative 10? Yeah, it is. Perfect. Okay, so we're going to split it up like this. We'll say we still have our 3x squared, and our negative 8 is less than or equal to 0. However, in the middle, we're going to split up this negative 10x into, let's put a negative 12x plus 2x. Now from here, when I do factoring by grouping, what I'm essentially doing is breaking this up into two groups of 2, and I want to divide out my greatest common factor for each. Here I ask myself, well, what can 3 and negative 12 both be divided by? And they can both be divided by 3. Also, notice this has 2 x's and this has 1 x, so we can divide both of these at least by 1 x. So let's write it like this, 3x parentheses, and here 3x squared divided by 3x is just 1x, and negative 12x divided by 3x, the x's cancel, and negative 12 divided by 3 is negative 4. Okay, and then back to here, we have 2x minus 8, and what can both 2 and 8 be divided by? Well, they can be divided by 2. So we'll write positive 2, and then we can put parentheses, x, and 8 divided by 2, or we'll have negative 4, is less than or equal to 0. Now notice, because there's an x minus 4 and an x minus 4 there, these two factors are the same. We can then factor out x minus 4, and our leftovers, once I factor those out, are going to be the 3x and the 2. And then we would say all of that is less than or equal to 0. Now I know that this is, the page is full right now, so let me go ahead and clean things up. I would encourage you to pause the video and finish taking the notes, and let's see what happens next. Okay, so now that I have these two factors, x minus 4 and 3x plus 2, I now want to set each of them equal to 0. So I can write x minus 4 is equal to 0, and 3x plus 2 is equal to 0. Okay, to get rid of the minus 4, we can do plus 4 and plus 4, and our very first solution is x equals 4. Now here, this is the first time it might be a little bit tricky today. 3x plus 2 equals 0. What do you get rid of first, the 3 or the plus 2? Well, we want to subtract 2 from both sides, Okay, and now we have 3x is equal to 0 minus 2 is negative 2. And then we divide both sides by 3, divide by 3, and we get comma negative 2 over 3. These are my two solutions. Okay, at this point, this actually clears us up in order to go ahead and finish the problem. So let's take a look at part B. Part B says to graph this to see visually what we're looking at. And we could say, okay, if we go to the right, positive 4, 1, 2, 3, 4, we can put our very first solution. And if we go to the left, 1, well, we know that negative 2/3 is just a little bit inside there. Okay. And then from here, I look at my a value. I know that my a value is this positive 3. And so my function, or my inequality, is going to open up. Now, a couple things. We know that this portion right here above the x-axis and this portion right here above the x-axis, those represent where all of my solutions are potentially positive. And then we know that on the bottom, let's use a fancy purple here, this is where the quadratic solutions would be negative. So for which part of this function are we looking for? We're looking for where it's less than or equal to 0. We're looking for the portion that is negative. And then how would you describe that negative portion? Well, hopefully, when you go to graph your number line, you'd say that negative portion is in between negative 2/3 and positive 4. Okay? It's less than or equal to, we can shade in our circles, shade in, and I would describe these negative solutions as being in between those two values. And if you'll recall, when our solutions are in between these two numbers, well, we just write our x value in between those two numbers. So we say our solution is negative 2/3 is less than or equal to x is less than or equal to 4. Okay, come join me for example 2 so I can show you how to do these on the quadratic formula. But remember, it's your choice. Do you want to use factoring by grouping, or do you want to use the quadratic formula? Completely up to you. Okay, here in example 2, this might look a little daunting at first, but this is really just kind of like our level 2 problems, just with a little bit extra. So when I look here, I don't see f of x, so I know I just want to set one of these sides to 0. And remember, you're always really trying to get this right side over here equal to 0, so we might as well just move those two terms. Okay, so what does that mean? Well, if I were to ask you, how to get rid of a minus 7x, what is the opposite of negative 7x? Well, we know that that would be positive or plus 7x. And what I do to the right, I have to do to the left. The question, though, is which one of these is a like term with 7x? Well, it is the 14x. Okay. And so 14x plus 7x, that's 21x. Okay. How in the world do you get rid of a plus 10? Well, we can do minus 10 and minus 10. Okay. And we know that 5 minus 10 is negative 5. All right. And then that lets us keep this greater than or equal to symbol. And we drop down our negative 4x squared plus 21x. And then, of course, negative 7x and positive 7x is 0. And 10 minus 10 is also 0. So that's all greater than or equal to 0. And notice at this point we have exactly the same thing as what we've had. Now from here, the next thing I notice is that my a value is not equal to 1. So if my a value is not equal to 1, I have to use either factoring by grouping, or I have to use the quadratic formula. Personally, in this case, whenever we have rather large numbers, I think the quadratic formula is probably going to be the easiest. Okay, so what does that mean? Well, we know that we have our a term, we know that we have our b term, and our c term. And if you will recall, the quadratic formula is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And in order to use this, we really want to replace every letter with a set of parentheses. So we can write x equals negative parentheses plus or minus the square root of parentheses squared minus 4 parentheses all over 2 parentheses. And let's go ahead and plug in our values. I know that my b term is 21, so where I see the b's, I can put 21. And then I know that my a term is -4, so -4 and -4. And lastly, I know that my c term is this -5, -5. And I kind of gave you a little saying to help you solve this. So if you will recall, first thing we want to do is simplify the outside. A negative times a positive is a -21. And then we can write plus or minus the square root of. And remember, the next thing we want to simplify is the inside, where I can say, okay, well, what is 21 squared? Well, y'all, I would encourage you that for 21 squared, I would grab a calculator, which I'm doing right now, and 21 times 21 is going to be 441. Okay, the next thing that I would have you do is I would always have you count up your negatives. We have 1, 2, 3, and we know that a negative times negative is a positive, and then a positive times negative is a negative. And then at this point, all you have to worry about is just multiplying 4 times 4 times 5. And 4 times 4 is 16, and 16 times 5 is 80. Okay. And then all of this is going to be divided by the bottom, which is 2 times -4, which is -8. Okay, not too bad, not too bad. All right, let's bring this up here, and let's rewrite it again. So now we have x equals -21 plus or minus the square root of, and here we want to do this 441 minus 80. So let's see, 441 minus 80 will give us 361 all over -8. Now from here, you're probably not too familiar with this, but the square root of 361 is actually a perfect square. So if you were to take 361, if you were doing this on your iPhone calculator, you could just flip it to the side, push the little square root button. You would see that the square root of 361 is just 19. Okay, so we now can write this like this. X equals -21 plus or minus 19 over -8. And this is where we get to split this up. We get to say that this is x equals -21 plus 19 over -8 and -21 minus 19 over -8. And I've kind of run out of room, so here's what I'm going to do. I'm going to pause the video and clean things up, and I would encourage you to pause your video, finish taking notes up to this point, and then let's see where we take this from here. Okay, so here we have these two sets of things, and so how in the world do you simplify this? Well, the first thing we want to do is go ahead and combine those two values on the top and combine those two values on the top. So it'll look something like this. -21 plus 19 is really -2 over that -8, comma, and -21 minus 19 is really -40 over -8. Now we know that in both cases, a negative divided by negative is a positive, so let's just go ahead and change that right there. And then we know that 2 over 8, well, both of those can be divided by 2, so that can reduce to 1 over 4, comma, and what's 40 divided by 8? Well, that's 5. Okay, so I have my two solutions, or I'm sorry, my two zeros. Technically, they're not our solutions in this case. So I have my two zeros, and let's see here, there's 1, 2, 3, 4, 5, and I know that 1 over 4 is less than 1, so it's just kind of somewhere in there, and positive 5 is going to be right there. And the next thing I say is, well, you know what, my a value was a -4, so we know that this graph is going to actually open down. And so let's kind of label the pieces of this. I know that this portion right here is below the x-axis, so that's negative. And this portion is below the x-axis, that's negative. And then I know that, let's see here, let's use nice green. Whoa, let's use a nice purple. I know that this portion is above the x-axis, so that's positive. Well, we're looking for the portions that are greater than or equal to 0, so greater than the x-axis, we're looking for those portions. And so we can say this. When we go to plot our number line, I put my 1 over 4, and I put my 5, I circle them. It's a greater than or equal to, so we can shade in between. And then I see that my positive solutions are in between those x values, and so I shade everything on the inside. Okay, so what does my solution set look like? What's going to look like 1 over 4 is less than or equal to x is less than or equal to 5. Because remember, it's every solution in between those two numbers. Okay? Like for instance, we know that positive 1 and positive 2 are in between 1/4 and 5. Those would be examples of solutions. And we know that 0 is not, so we know that that is not a solution. All right, y'all. I hope that these videos have helped, and I'll catch y'all in our next video series.